Zener diode characteristics and Zener as aim to plot volt-ampere characteristics of Zener diode. To find Zener breakdown voltage in reverse biased condition. To calculate static and dynamic resistances of the Zener diode in both circuit diagram, forward bias. Circuit diagram, reverse bias. Components: Zener diode 4735A, 1 number. Resistor 1 kilo ohm, 1 number. Equipment required: breadboard. 1 number regulated power supply 030 VDC. 1 number digital ammeter 200 milliampere 1 number digital voltmeter 2 V/020 VDC. 1 number connecting wires 5. Specifications: breakdown voltage equals to 5. 1 V power dissipation equals to 0. 75 W. An ideal PN junction diode does not conduct in reverse biased condition. A Zener diode conducts excellently even in reverse biased condition. These diodes operate at a precise value of voltage called breakdown voltage. A Zener diode, when forward biased, behaves like an ordinary PN junction diode. A Zener diode, when reverse biased, can either undergo avalanche breakdown or Zener breakdown. Avalanche breakdown. If both P side and N side of the diode are lightly doped, depletion region at the junction widens. Application of a very large electric field at the junction may rupture Zener diodes are manufactured with a great variety of Zener voltages, and some are even variable. Some Zener diodes have an abrupt, heavily doped p-n junction with a low Zener voltage, in which case the reverse conduction occurs due to electron quantum tunneling in the short distance between p and n regions. This is known as the Zener affect. After clearance, Zener diodes with a higher Zener voltage have lighter doped functions, which causes their mode of operation to involve avalanche breakdown. Both breakdown types are present in Zener. Especially stabilized power supplies. They are also used to protect circuits from overvoltage. Working of Zener diode in reverse bias. A Zener diode operates just like a normal diode when it is forward biased. However, a small leakage current flows through the diode when connected in reverse baked mode. As the reverse voltage increases to the predetermined breakdown voltage, VZ, current starts flowing through the diode. The current increases to a maximum, which is determined by the series resistor, after which it stabilizes and remains constant over a while. Procedure forward. Biased condition. 1. Connect the circuit as shown in Fig. 2. Vary VZF gradually steps of 0.1 volts up to 5 volts and note down the corresponding readings of observations. Zener diode in forward biased condition. RPS voltage forward voltage across the diode VZF volt. Procedure: reverse biased condition. 1. Connect the circuit as shown in Fig. 2. Vary VZR gradually in steps of 0.5 volts up to 8 volts and note down the corresponding readings of I. Zener diode in reverse biased condition, RPS voltage reverse voltage across the diode VZR, volts. Calculations from graph: static forward resistance RDC equals to VZF EZF. Dynamic forward resistance RAC equals to delta VZF delta IZF. Static reverse resistance RDC equals to VZR. Precautions. 1. While doing the experiment, do not exceed the ratings of the diode. This may lead to damage the diode. 2. Connect voltmeter and ammeter in correct polarities as shown in the circuit diagram. 3. Result. Conclusion. Questions and answers. 1. What is a Zener diode? How it differs from an ordinary diode? Answer. A Zener diode is heavily doped, with doping concentrations greater than 10 power 18 per cubic centimeters in both the P and N regions, whereas an ordinary diode has doping concentration of 10 power 17 per cubic centimeters or less. 2. Explain the concept of Zener breakdown. Answer. Zener breakdown occurs because of the high electric field. 3. What is avalanche breakdown? Answer. Four. What are the advantages of Zener diode? Answer. Less expensive than other diodes. High performance standard. Protection from overvoltage. Ability to regulate and stabilize circuit voltage. Greater control over flowing current. Usable in smaller circuits. 5. State reason why an ordinary diode suffers avalanche breakdown rather than Zener breakdown. Answer. A general proposed diode is lightly doped, so it suffers an avalanche breakdown rather than a Zener breakdown. 6. If impurities in a Zener diode increases, what happens to the
Thank you for watching. Please subscribe, share and comment if you like.